Hi, boys and girls. I'm very happy you are here again with me. I'm Mr. Peck here. Welcome to the channel. I'm going to help you out another questions on conservation of linear momentum. Alright, let us jump into the questions. So, the nucleus of an atom undergoes radioactive decay with the emission of an alpha particle. If the nucleus is at rest initially, and has a mass of 3.8 exponent negative 25 kilogram, while the alpha particle has a mass of 6.6 exponent negative 27 kilogram and velocity of 1.8 exponent 7 meter per second, find the speed of the daughter nucleus. Okay, so what actually happens here in the questions? Okay, this is seems to me something like explosion. Yeah, explosion. So if you see here, we have a nucleus. Okay, let us highlight. We have a nucleus initially at rest. So this is regarding the initial velocity equal to 0. Okay. The mass of the nucleus is 3.8 exponent negative 25. This is the mass of the nucleus. And the alpha. Okay. So the alpha particle has a mass of, okay, we have the mass of the alpha. Okay, we have the mass of the alpha. So, sorry, we have the mass of the alpha, put as mass of alpha, and this velocity, while okay, this velocity, this is alpha is born after the explosion, isn't it? Because after the decay, we can say this decay is something like explosion happens. After the explosion, only have alpha. Okay, so this alpha is born after the explosion. So this is actually the final velocity for the alpha, velocity of the alpha. What is the speed of the daughter? Okay, we have the daughter nucleus. So this daughter should be born after the nucleus, after the explosion. So we put this as mass of the daughter. Anyway, I already labeled here. As you can see, is the nucleus undergo explosion. So it after explodes, it forms two particles. One is alpha, one is daughter. Alpha I denote as number 1, daughter as denote as number 2. Okay, we have the total mass of the nucleus, we have the mass of the mother nucleus, and we also have the mass of the alpha. We don't have the mass of the daughter, but never mind, because daughter is actually part of the mother, right? We can actually just use the total mass minus out the alpha. We got the mass of the daughter, isn't it? Okay, it's not a problem. We also have the velocity of the alpha, 1.8. This velocity of the alpha after explosion. Why I put a negative sign there? You learned about explosion before. Explosion is something like, a bullet with a pistol. Yeah. After you fire off the bullet moves to the front, but the pistol recoil backward. Yeah, it moves backward. The bullet moved to the right, but the pistol moved to the left. For explosion, one of the members must move in the opposite direction. Okay, so same thing for explosion for radioactive decay. Yeah, before explode, one thing I forget to write. Yeah, for nucleus initially at rest, so initial velocity is 0. Initial velocity is 0. So so the alpha, after explosion, alpha must move backward. So daughter move forward, the alpha move backward. So the alpha move to the left. Okay, so when move to the left, you must put a negative sign. Okay, negative sign, negative 1.8. Okay, so now let us do the questions. First, we find the mass of the daughter. We know that mass of the nucleus equal to mass of alpha plus mass of daughter. So we just substitute all the information we have here. We have the mass of the nucleus after explode, then born the alpha and the daughter. So we got the mass of the daughter is 3.734 exponent negative 25 kilogram. That is the mass of the daughter. Okay, so for explosion, it also apply the principle of conservation of momentum. Okay, no matter it's elastic or inelastic collision, both apply conservation of momentum. So to find the final velocity of the daughter. So m1u1 plus m2u2 equal to m1v1 plus m2v2. So just substitute all the information we have. So we know that for explosion, initially the velocity is 0. So we can say initially this thing equal to 0. Initially no velocity, 0 velocity, so 0 momentum. And then this is the alpha, and this is the daughter. Okay, the daughter. So mass of the alpha is 6.6. So let's substitute. 6.6 exponent negative 27, and we have the we want to find the mass of the we have the velocity of the alpha, which is negative 1.8. Negative, don't forget to put the negative. Many students forget the negative sign. For explosion, one of the member must move in opposite direction, so must have negative sign. So negative 1.8 exponent 7, right? And now the daughter has a mass we got just now is 3.734 exponent negative 25. Yeah, so we can find the velocity of the daughter. Yeah, so daughter nucleus. So we got the answer as the daughter has a velocity of positive 3.18 exponent 5 meter per second. So this positive tells us it's moving to the right. Okay, so you must give the direction. Yeah, you must give the direction. So for explosion, one move to the left, one move to the right. So the daughter move to the right. Okay, you must give magnitude and direction both. So that's it for explosion. I hope you enjoyed the videos. Please stay tuned for the upcoming videos. Thank you. Bye.